Find your question?
Number 7.
From which one?
The 3.2. That one.
So the 225a squared.
Yeah, and minus 36.
I got it. Now, if we look at this here, 225a squared minus 36b squared, is there a greatest common factor between these two here? So 2 definitely won't go into both of them. I'm going to just divide it by 9. 36 divided by 9. Well, there is a greatest common factor of 9. But let's say we didn't notice that. We can check by taking the square root of 225, which is square root of 36 is 6. So our difference of perfect squares, we would have plus, we would have minus. We'd have 15a, 15a, 6b, 6b. So the difference of perfect squares for this here would be 15a plus 6b times 15a minus 6b. Yes? So this is factored, but it's not technically factored completely. Now, I believe the homework just said to ask, or just asked for you to factor.
Wait,
Number 7. Looking at 15a and 6b, is there a greatest common factor between 15 and 6? Is there a number that will go into 15 and 6?
Yeah,
3. So technically we can factor a 3 out, which does leave us with 15 divided by 3 is 5. 6 divided by 3 is 2. Well, we also have a factor of 3 in the, which would give us 5a minus 2b. And well, 3 times 3 is 9.
which was just 3.2?
Oh, so I did do it.
So the 3.2. So 9 times 5a plus 2b times 5a minus 2b, is it completely factored? Yes. Yes. Mm-hmm. Number 7. But I did take 15a plus 6b times 15a minus 6b. But if the problem asked for it to be completely factored, I believe it just asked for it to be factored. I took either one. So 3.2, you're holding up 3.12.
Oh, there should be another copy.
3.1. $3.1, 24.
Factor the negative.
There's 20. We have to do that one too?
Mm-hmm.
Dang it. I thought that was good.
So the first thing we're going to do is factor the negative out, which will give us 15w squared plus w minus 28. So we'd have our 2 sets of parentheses with 3 spaces.
Oh, you factored the negative out first?
Mm-hmm. If the first, or the number in front of w, or the term being squared, is negative, we factor it out. If there is a greatest common factor also, we would factor it out too. But there's not. Now, since the third term is negative, our signs are opposite. Now we need to find the factors of the first and third term. Well, 15w squared, we'd have w and w. 28, 1 and 28, 2 and 14, 3 doesn't work, but 4 and 7 does. So I'm going to put 3 and 5. Four and 7 here. We can check it. 3w times negative 7 is negative 21w. 4 times 5w is plus 20w, which gives us negative 1w. So we can change the signs, which would give us the correct answer. Because and if we checked it again with the new signs, 3w times 7 would be positive 21w minus 20w, giving us a positive 1w, and we have this here. Also, you do need a graphing calculator today. Yes. We good with this here? Yes. Okay. I'm going to put it off for a little bit longer. Putting new batteries in them. What we're looking at today is more ways to solve. Yeah. Yeah, it still works. It's just letting you know that the batteries are about to run out. So there's there's one way out of these three we've already gone over for solving quadratics, and that is factoring, because we've gone over that already. There are two more that we're going to go over in this here, and one of them is by graphing, and the other is using the square root method. Now we will finish up this section of notes 3.3 with some more solving by factoring, but the one we want to look at first is graphing. So we'll graph the quadratic equation, and we're trying to see what value of x will make the function be 0. We want to see where it crosses the x-axis, what the x-intercepts are, because the x-intercept will be the solution, because it'll tell us what value of x will make the function be 0. It's going to tell us what value of x will make the y value be 0. So when we solve a function or a quadratic by graphing, one of the first things we need to do is get it equal to 0. We need to get it equal to 0. So what do we need to do to this first one here to make it be equal to 0? Nothing. It's already equal to 0. So we can graph it. Clear all these out. Make sure my equals is cleared out. Clear that out again. So first thing you need to do is turn your graphing calculator on. Now to graph a function, the first thing we need to do is hit y equals. The button is highlighted in red. for which one we're going to hit first. So y equals, you should get your screen should look something like this here, yes? If you do have something typed into any of the y1 through y9, use the up and down arrows to kind of get to it and hit clear it out. We don't want anything there. So what we want to do is type in the function itself. Now the function they told us that we're trying to graph is x squared minus x minus 6. So over here, the first thing we're going to do is hit our button for x. It's the button here that's actually x tau theta n, the one next to alpha. Yep. Squared minus x minus 6. So we're typing the whole function in.
You have to put
So it look just like we have it up there, yes. The only difference is that you don't have the little color boxes next to yours. Questions on any of this here? We got it?
I don't know.
Let's restart. So x.
Yeah. And then it's squared. Okay, now we're good.
Minus x minus 6. Once you get it all typed in, again, we're wanting to do what? We want to graph it, yes?
Yeah.
So hit graph. So, do we all see this graph here? I think except y'all's is not blue.
It's have the same thing.
No, this is it.
Hit graph.
Huh?
I was joking.
Zoom. So enter. So we'll have to put first. Zoom 6. There we go. Yeah. Now, if for some reason it's saying error window, so if it does give you a window error for some reason, it means someone's gone in here and messed with the numbers here. So zoom standard, because if for some reason the window doesn't look right, we can go zoom standard. So it's not showing us what we want. Zoom 6, it's zoomed in because we want it to be here. Yeah. Because if for some reason the graph's off the screen, it's saying a window error, zoom 6 will fix it. If for some reason an error does show up, especially on the test, ask, I will fix it there. Now looking at this here, we're trying to see where it crossed the x-axis. What values of x will make the function equal 0? And we do see that it crosses, guys, we do see that it crosses the x-axis in 2 locations. Now to get a better view of this, we can look at a table. To get that, we're going to go second graph. So again, we're trying to find out what value of x will make the y value be 0. What value of x? -2. Because we can go up and down to try to find it. One of them is -2.
Mine says 3.
-2. When x is -2, the y value is?
So, and 3, right?
When x is 3, the y value is?
0.
Because if I look back at the graph, how many times does it cross the x-axis? So we should have 2. So x is equal to -2 and x is equal to 3. Because when x is negative 2, it should equal 0. And we can check this by plugging negative 2 in for x. So we say negative 2 squared minus negative 2 minus 6. Well, negative 2 squared, negative 2 times negative 2 is 4. Negative negative 2 would be plus 2 minus 6. Well, 4 plus 2 is 6. And 6 minus 6 would be 0. We can do the same thing for 3. 3 squared minus 3 minus 6. Well, 3 squared, 3 times 3 is 9. And we have minus 3 minus 6. Well, 9 minus 3 is 6. And 6 minus 6 is 0. So negative 2 and 3 are solutions. Now be careful, because there is one, I think y'all were saying negative 6. That's when x is 0. That's the y-intercept. When solving by graphing, we're not finding the y-intercept. We're finding the x-intercept. We're trying to find out what value of x will make the y value be 0. Let's look at this one here. Now, what did we say these equations had to be equal to? 0. Before we can start, we need this equal to 0. Exactly. Because before we can start, we need this equal to 0. Now, negative 2x squared, negative 4x, and negative 2, none of these are like terms. Which tells us we have negative 2x squared minus 4x minus 2 is equal to 0. Now, when we solved by factoring, and we try to factor this, one, we need to factor out a greatest common factor to make it easier to work with. This one technically has 2. We do have the negative, and we do have the 2, because 2 is divisible by all 3 terms. But with graphing, and especially the graphing calculator really doesn't care. It will still graph it just fine. So we'll clear out the first row and say negative 2x squared minus 4x minus 2. Questions on how we type this in? And once we get it typed in, we will hit graph. You can hit enter. There's nothing wrong with hitting enter. And when we hit graph, does it intersect the x-axis?
What?
So we can go second table. So we might have to scroll up or down on some of them to find it. But do we have an x value that makes the y value be 0?
Yes, you do.
Negative 1. Now, incidentally, for this one here, it does intersect the x-axis but does not cross it. What we call this point where it touches the x-axis is that point, that solution has an even multiplicity. It has an even number of zeros. Well, it's just saying that x is negative 1 and x is negative 1.
You know that's true.
All quadratic equations will have 2 solutions. They may not be unique solutions where we have 2 different values. It could be that it has the same value. So here, x is equal to negative 1. And actually, x is equal to negative 1. Questions on this here? Now, when we factored out the negative from it to help it make it be easier to factor, yes? And if we factor that out, it would turn into 2x squared plus 4x plus 2. Now I'm just going to divide that negative out on both sides, which would give us this here, yes? And this is kind of interesting. Y equals, you don't have to type this in. But as we can see already, these are two different equations, yes? Graph. They do look completely different, yes? But if I look at the table, what is the solution for the one in red? What value of x will make its y value be 0? It's still -1, yes? By dividing that negative out, it changed every other point but the solution. The solutions are still the same. Now in factoring, we would still need that negative. If I was just factoring, I would still need it as negative 2x squared plus 4x plus 2. But if we're solving, really this says that we can divide the entire equation by -1 and still get the same answer. It still gives us the same values. We also said there's still a greatest common factor of 2, yes? By that same logic, it means I can divide everything by 2. So if I divide 2x squared plus 4x plus 2 by 2, I have x squared plus 2x plus 1, yes? Let's see what the graph looks like. Well, that's different than any of the other two, yes? When x is -1, what's the y value? It is still. If we're solving, we don't have to leave that greatest common factor out there. We don't have to leave that negative out there. Because in solving, I can just divide it out. It'll still give us the same answer. It's a different graph. Everything else but the solutions are different, but we can still find the solutions. Does that make sense? So factoring, we have to leave that greatest common factor there. We have to leave that negative there. But if I'm solving, I can multiply or divide it out to make it easier to solve. Questions on this here? Let's look at the next one. X squared minus 8x plus 12. Well, it is already equal to 0, yes? So in the graphing calculator, throw all these out, we can do x squared minus 8x plus 12, I believe is what the equation was, yes? And once we type it in, we can hit. So it crosses the x-axis at 2 points. We could count on the x-axis to find it, or we can say second graph. Scroll down. So 6 is one of them, and the other is 2, yes? So here x is equal to 6, and x is equal to 2. Questions on any of this here? Questions on anything we've done so far? Do we like graphing so far? Let's look at the next one. 1/2 x squared equals 6x minus 20. So what's the first thing we need to do to solve this? And when we do that, the 1/2 x squared minus 1/2 x squared becomes 0. Negative 1/2 x squared plus 6x minus 20. We get this here. Now, again, we can graph this. And the first step in graphing is to hit y equals. Now, we'll clear the previous one out. Now, we do need to type in a fraction. Alpha y equals enter. Alpha y equals enter. Negative 1/2 x squared. Whichever number, if the first number you're plugging in is negative, we use the negative. Anything after that, we use the minus. Questions on this here? You got it typed in? Hit enter. So where did it cross the graph? Where did it cross the x-axis at? Might need that to be negative. It did not cross anywhere, did it? So this one here has real it has solutions, but they're not real solutions. We wouldn't call them fake, we'd call them more imaginary or complex. But it doesn't have any real solutions, and we'll have to leave it at this point for now, because we do not have any methods, or we have not gone over a method to solve this. There are ways to do it. Graphing cannot do it. Factoring cannot do it. We can factor it, but really we need to know the solutions to be able to factor it. We kind of work backwards. But at this point here, if we're trying to solve this by graphing, we would say that it has no real solutions. Questions on this here? Let's look at the next one. 4x squared minus 12x plus 9. So 4x squared minus 12x plus 9. Go on and type that in. When you get it typed in, hit graph. Let's see here. Let's do 0 to 10 by 0.1. Window 0. Actually, let's go from negative 5 to 5.5. Let's go from negative 5 to 5. So I'm messing with the scale of the graph. So does it cross there? Well, it's hard to tell. It's hard to tell what's going on. And whenever we're graphing, if it does not intersect at nice numbers, it's hard to tell. So if we go second graph, second, okay. Okay. Looks like the program decided to freeze. Even if we looked at the table and between 1 and 2, we don't have any values. And 1 and 2 is not 0. So what we can try instead is to solve this by factoring. Solve it by factoring. There is no greatest common factor between the three terms. Now, since the third term is positive, the signs are the same and match the sign of the middle term, which would be negative and negative. Now we need to find the factors of the first and third term. Well, with our 4x squared, our factors of x would be x and x. Factors of 4 are 1 and 4, or which one do we want to try? That's 4 here. Factors of 9. 1 and 9, or 3 and 3. So we can check this here. 4x times negative 3 would be negative 12x. Negative 3 times x would be negative 3x, which gives us negative 15. So we need to change something. What do we want to change? I'm going to change the 1 and 4. 2 and 2. And if we check this again, 2 times negative 3x is negative 6x. Negative 3 times 2x is negative 6x, which gives us negative 12x. So this does have a solution because we're able to factor it. 2 sets of parentheses being multiplied together, 2 things being multiplied together to equal 0. So one of them must be 0. So we're either saying that 2x minus 3 is 0 or 2x minus 3 is 0. Now at this point here, we can solve for the value of x. We can add 3 to both sides, telling us that 2x is equal to 3. Yeah. Divide by 2. X is equal to 3 halves, which as a decimal is 1.5. So it's intersecting between 1 and 2 on the x-axis, yes? Now we can solve the other one. Add 3 to both sides. Tells us 2x is equal to 3. Divide both sides by 2, which tells us x is equal to 3 halves. Well, we do have a solution, and incidentally, they're both the same. Yeah. So we do have 2 solutions. They're just not unique to each other. There's not different solutions. They're the same thing. But we get this here. Any questions on any of this here? We're going to stop there for today. We will finish these tomorrow.